students, you're welcome to this section or session part 3, chapter 3 part 5, okay, called optical networking. Let's quickly go through this, okay. Without much ado, let's begin. Now, this is the introductory part of optical networking. You know, because we want high bandwidth, increased bandwidth. Because of that, for that singular reason, we've been pushing for optical fiber networking. We've been really pushing for optical fiber networking because we want a bandwidth, a very big bandwidth that is capable of handling big data and high-speed data. So, because of that reason, we'll be pushing for optical networking. Okay, we'll be looking out for optical networking solutions that are almost beyond the imaginations of most advanced networking systems that we have. So because we are in the Gigabit Ethernet era and the 10 gigabit, 10 gigabit and hundreds of gigabits, so we have a big speed and we carry big data. The boundaries are super high, over 1000 megahertz and 600 to 1000 megahertz. So we started looking out for optical networking, okay? Optical networking as a solution to the long distance transmission, as a kind of solution for long distance transmission, for wide area network, and for metropolitan network, for campus network, for local area network. And because of this, then the telecommunication enjoys a very fast speed connectivity. Because of optical fiber connectivity, the telecommunication system today enjoys super fast speed delivery. Okay, so cable companies are already using the high bandwidth capability of fiber to distribute cable programming as well as the data throughout the service area that they cover. Okay, they're doing programming on this and they are delivering cable on this to cover those areas that they are operating on. Now let's take a look in, still on the introduction. Optical networks are becoming a major part of the data delivery in homes now, not only in the offices. Even in our homes, we're using optical networks today, right? And in businesses, we're using optical networks to connect because we want fast speed data, right? Okay. And then also for long haul carriers, for long distance carrier, we're looking out for optical fiber transmission. The telecommunication industry has been using fiber for carry long haul traffic for many years now. Telecom has been using fiber for many years now. Now, some major carriers are merging with cable companies. Okay, the UTP cables, the twisted pair cables. So some of these carriers, they are merging with this twisted pair cables company. So they don't pose so that they are supposed to provide high bandwidth capability to homes. So they are merging them together so that we, at the end of the day, we can have a high bandwidth in our homes. Now let's go to this part we call the Sonnet hierarchy data rates. Now, what is Sonnet? Sonnet is synchronous optical network. This one is derived from, this S is synchronous, this O is optical, and this is a network. Sonnet is a synchronous optical network. Okay, so what we are saying here, we're looking at a synchronized optical network, right? Now, these are the bit rate and these are the capacity, the bandwidth, the capacity. Now, these are the different signals. OC means optical carrier. Optical carrier. So when we say OC1, it's also called ST1, STS1. STS is called synchronous transport signal. Synchronous transport signal. Because the carrier is like a transport network. It carries the optical signal and deliver it from point of transmission to point of reception. So the OC1, or what you call the STS1, has a speed of 51,840 megabit per second. Okay, can deliver this 51,000 speed, 51,840 megabit per second, and the capacity is 28 ds. 28 ds, okay, 20 data signal. So it can carry 28 ds, which is 1s or 1 ds3. Then we have the third, the one we call OC3. Excuse me. OC3 carries, which is also called STS3. Okay, we already said STS is a synchronous transport signal. Okay, STS3 and OC is optical carrier. Optical carrier 3, which has another name STS3, has a data rate of 155.52 megabit per second. 155.52 megabit per second. Okay, you can see. Okay, and this one has a capacity of 84 ds. 84 ds. Now OC12, that's optical carrier 12, which is STS12, can carry 620. The speed is 620.080 megabit per second, and this one has a capacity of 336 ds. Okay, now OCS 48 can carry 2.4883 to gigabit. This is huge. Now this is gigabit per seconds. So, and the capacity is 1344 ds. Then the OCS to OC192, which is STS 192, can carry 9.9, almost approximately 10, you can say 10 gigabit per second. So you can see how the speed, the bandwidth, and the signal itself are being carried using what we call synchronous optical network. Okay, now let's move to the next one. We have Sonnet, synchronous optical network, or what we call synchronous digital hierarchy. The SDH. SDH is synchronous digital hierarchy. So they are used interchangeably. Synchronous optical network, synchronous digital hierarchy. They are used interchangeably, meaning the same thing. Okay. Now, so when we have a Sonnet, that's we are saying optical network. Now, a synchronized optical network. When you have Sonnet, when it carries digital signals over, whenever you carry digital signal over Sonnet, the signal is essentially always encapsulated, meaning it's carried in an envelope. Okay, because there's a carrier that will carry it. A carrier. The envelope is like the carrier. Let's say you send you a letter. When you write a letter, in those days, before telephony, before these things, we used to post letter, right, from one place to another. So you write a letter, you have to put it in an envelope. The envelope helps you to wrap the letter, encapsulate it, and then it's sent from a place to place. So the envelope is acting like the carrier, okay? So when we say synchronous optical network or synchronous digital hierarchy, whenever we say when you carry digital signal over this network, optical network, the signal is essentially encapsulated within the optical carrier. Now we take a look at this table, which is similar to what I just explained, table 3.1. We take a look at this table to show the data rates of the different signal and the bit rate and the capacity, okay, of the different signal. I think we've explained this one in the previous table, so let's not waste time here. Let's move on because we have a lot to do. Then we have what we call FTTB. FTTB, we say another architecture in place is fiber to business. This one means fiber. FTTB means fiber. This F is fiber to business. Okay, this is fiber to the business. Fiber to the business. FTTB, fiber to the business. Okay, that's what this means. So we say another architecture that is normally in place is fiber to business. A fiber connection to business provides for the delivery of all correct communication technology, including your data. When we talk about business now, your streaming, your video, your voice, your conferencing, so all of these ones are called FTTB. They fall under FTTB concept. Now let's take a look at optical Ethernet. Remember the conventional high-speed Ethernet networks operating over fiber. So what they do is they connect the conventional one or the traditional one and make it they synchronize it with a fiber, optical fiber. Okay, that's what we do. We synchronize with the optical fiber. We make it to operate over fiber. Now this is called optical Ethernet. So when you use optical fiber in your traditional network system, it becomes a optical Ethernet. Now it uses numerical values like this: 10 base F, 10 base F, 100 base FX, 1000 base XX, SX, then 10 gig. So these are, for optical fiber we use base F, not base T. Okay, we say 10 base F, 100 base FX, 1000 base XX, and 10 gigabit. Okay, so these are the acronyms for optical Ethernet. Now let's go to the next one, which says fiber helps to eliminate 100-meter distance limit associated with or shielded twisted pair. Remember, you know, the distance limit for or twisted shielded or twisted untwisted pair cable that we talked about in chapter 2. The distance is always around 100 meters. After 100 meters, we start having a lot of attenuation. So, but with the help or with the use of optical fiber, we can go as far as possible, even a long transmission range, okay, across even big oceans. So without much attenuation and dispersion. Now let's move on quickly. We've already identified this. I've shown you connectors. These are the SC connector, ST connector, MT RJ connector. This one is very popular. MT RJ connector for optical fiber. Okay, you see, look at it. Look at them. Okay, these are the samples of connectors we use in optical fiber. Now let's go to building distribution. If you take a look at this figure, let's start from point. We label them point A, B, C, D, E, F, G. We look for them G. Okay, H. Where's H? G, H, I, J. H is here. Okay, G, H, I, J, K, L, M, N. L, M, N, right? So we label them like this. Now let's begin to explain them one after the other. If you take a look at this, the first one is called the main fiber feed, the distribution board. Okay, the building distribution. Okay, so this is at this point. Let's say this is a campus. Then the main one comes into the campus through this place. As you see, this example is a simple fiber network for a building. Okay, now fiber lines consist of minimum of two fibers. They consist of minimum of two fibers, one for transmit and one for receive. One to transmit the data or signal, the other one to receive. Now fiber networks work in full duplex mode, meaning that the link must be able to simultaneously transmit and receive. When we say full duplex mode, we explained this one before in the previous chapter, right? When we say full duplex mode, we are saying that the link can be able to transmit and receive at the same time, right? Okay, so meaning this link can be able to transmit and receive simultaneously, right? Hence the need for two fiber in each link. Every link you need two fiber, one to transmit, one to receive, one to transmit, one to receive. Now let's move on. Now if you look at item A, is the main fiber feed for the building. This is the feed, like the distribution board. Okay, this is the feed, building distribution. Okay, this is the main fiber feed for the building, and it's also called the building distribution fiber. Okay, and then the two fiber for the building distribution link terminates into the main fiber cross connect at B. This one terminates at the main fiber cross connect at point B at B. Now a fiber cross connect is the optical patch panel. This is an optical patch panel. Okay, here is an optical patch panel, meaning when the optical fiber comes into the building, it has to go straight to the optical patch panel or the telecommunication closet. Okay, where from here we will go to distribute to every terminal or every other aspect of the building, right? So we say fiber cross connect is the optical patch panel used to connect the fiber cables to the next link. From here we connect. You can see it's given its own it's like a closet. It's given its own environment. Now here is the main cross connect, the main fiber cross connect, which houses everything that is coming here, terminates here, from here goes to every other part of the building. Now let's move on. Now if you look at C, C represents the active equipment. The active equipment in the main building closet in the building, okay? In the main distribution closet of the building. These are the active equipment, like you're going to find your switches, your hubs, your router, all of them, you know, that telecommunication closet. So they are in this C part, okay? They are in this C part, okay? Now the active equipment could be a router, like I said already, could be a router, could be a switch, or could be a telephone PBX, the private branch exchange. That's the meaning of PBX, private branch exchange, a telephone PBX. So here you have telephone PBX, you have a router, you have switch, and so on and so forth, all here. They are called the active equipment in the telecommunication closet. Now item D, let's go to D here. Item D shows the jumper. You see, from here we link the fiber cross connect to the active equipment. So these are what? D is what? We say the jumper. They called D is called the jumper connecting the main fiber cross connect from item B to the active equipment at C. So D are the jumpers, like the jumper cables, the cables that brings the main fiber cross connect from this part to the active equipment, where you have the switches, the router, and the telephone PBX. So this is C and D explained as well. Now let's move to the next part of it. Now the next part of it is to look at the active equipment. We need some types of optical interface. This active equipment, we need some, because the router and everything, they will need some kind of optical interface, because this is different from the UTP cabling. Now you are using optical fiber, so they will therefore need optical interface for optical electrical signal conversion. So because the signal that was coming as optical, as light, pulses of light, they need to be converted to real signal, right? To real electrical signal. So they need an interface for conversion, optical to signal conversion. So in one of those interface will be what we call the GBIX. The GBIX is pronounced as GBIX. Okay, the GBIX and the Zenpack. These are two interfaces. The GBIX is for 1 gigabit Ethernet, and the Zenpack is for 10 gigabit Ethernet interface. So if you are using 1 gigabit Ethernet interface, you use what we call the GBIX. When you are using 10 gigabit Ethernet, you have to use the Zenpack interface to convert the light impulses that is coming into some electrical signal that will be understandable by the system. Now the GBIX is a gigabit interface converter, while the Zenpack is 10 gigabit converter for transmitting and receiving higher speed signal over fiber optic lines. Okay. Now the GBIX modules are designed to plug into interfaces such as router and switches. These interfaces are designed to plug into router and switches, okay, so that the light signal that is coming, that is connected from the fiber cross connect in the telecommunication closet into, or the patch panel into the telecommunication closet via jumpers, there is an interface that helps to convert that light impulses into electrical signal. Okay, into electrical signal. Now let's move on quickly. Now after D, we have item F. Okay, we have item remember the E. Item E was actually the interface. The interface, the GBIX and the Zenpack that I talked about. That's E. Now after E, let's go to what are these lines, these cables. What are they? Item F and G. Look at this is F, and this one going down is G. Item F and G shows two fiber pairs patched into the main fiber cross connect connect it to the intermediate distribution closet. So this one, you know, this is the make cross connect. Now from the make cross connect, you have to send to intermediate. You know, in a building, you have the make cross connect is the one that the optical fiber enters from where it's coming from the telecommunication. Okay, then after that you have to send them to what we call intermediate cross connect, the IC, intermediate cross connect fiber. Okay, so this F and G, they are the two fiber pairs patched into the main fiber cross connect, connected to the intermediate distribution closet. Okay, now the fiber F and G are called the interconnect, or what you call intermediate cross connect. Either you call them interconnect or you call them intermediate cross connect fibers. Okay, now the fiber, why you call them interconnect? Because they connect from the main telecommunication closet or mesh patch panel to the intermediate patch panels. So that's why we call them interconnect or intermediate cross connect. Okay, so these two F and G, they are called the interconnect fibers. Now the fiber terminates into IDC fiber cross connect of item H and I. Now where is item H and I? This is item H, right? This is item H and this is I. These are the two intermediate cross connect. So they come into these two fiber connects the main cross connect to the two intermediate cross connect. Okay, now let's move on quickly. Okay, so you can see these two, they are the intermediate cross connect. These two, H and I, they are the intermediate cross connect. Now let's move. Now let's talk about J. Let's talk about J. After H, I, then we have J, right? J is a jumper. Take it this one to another active equipment. These two this J, you see this line is called J. This line and this line, they are J and K, and they be shown with these arrows. Okay, they are just fibers. They are jumpers. They are jumpers that connect this from intermediate cross connect, okay, to the two active equipment. This active equipment could be patch panels or could be your telecommunication closet where you terminate, where you have your switches and routers, okay, and your telephone PBX. Okay, so this J and K, they are jumpers. J and K's are jumpers that connect the fiber cross connect to the IDC active equipment. Once again, the active devices must have a GBEX and ZPAC or some other interface for the optical electrical signal conversion, because you need a GBEX and a ZPAC to always convert the signal, the light signal, into electrical signal. Okay, now let's move on quickly. Now we go to the two deep rule, what we call the two deep rule. The two deep rule says that we say there is a general rule for fiber. We say the two deep rule says a general rule for fiber is the distribution in a building should be limited to 2 deep. What do we mean by that? We're saying that the distribution of the network of the whole system should be connected to 2 deep. Now this means that a building should only have the main distribution and the intermediate distribution that fits the horizontal distribution to the work area. You remember in the when you were using your twisted pair cabling, we have main distribution, intermediate distribution, and horizontal distribution. Okay, but this one, the optical fiber uses only 2 deep rule. You only use the main cross connect and the intermediate cross connect. Okay, you cannot have the third case. You cannot have the horizontal cross connect. In untwisted pair cabling chapter 2, we talk about main cross connect, intermediate cross connect, and horizontal cross connect. But in optical fiber, we only use 2 rule. There's a rule called 2 deep rule, meaning you only use the main cross connect and this intermediate cross connect. These two, they are together as intermediate cross connect. So you cannot have another cross connect. That rule is called the 2 deep rule. Is that okay? Let's move on quickly. Now here is a campus fiber distribution. Here is a campus. This is a telco demarcation. This is at A, the telecommunication. This telco is a telecommunication. The signal comes into 1. Let's say this is a part of a building, and then from here, the using jumpers, it goes to this to this intermediate cross connect, and also go to this 2, okay, in another part of the building. Okay, then from here it goes to 5, it goes to 11, it goes to 12. Okay, from here it connects to 2 and 3 are linked together, right? Then connects to 4, connects to 7, connects to 6, 5, and link back to 5, and or 5 is take it to 6, and then 6 take it to 7, 7 take it to 8. Okay, then from here 1 is linked with 9, 10, and then back to 4. Okay, so this symbol is simply called the fiber patch distribution center. Each of these are fiber, where you have your router, your switches, and your telephone PBX. Each of these block, okay, is your fiber patch distribution. So in a campus, this is how we net every, there are many buildings in a campus, in one campus. You have different faculties, you have different departmental building. So let's assume each one is a faculty building. So every faculty has its own, what we call the fiber patch distribution center, where everything is sent or to every corner that needs the work area, connected to the work area. Each one connected to its work area, and so on and so forth. So this is an example of a design of a campus fiber distribution. A map of the fiber distribution for campus network is what we've just seen. This is a map of the fiber distribution of a campus network. Okay, you can design yours differently. This is just one of the ways. Now this map shows how the fiber is interconnected and the data is distributed throughout the campus. This is called logical fiber map. This is called a logical fiber map. Okay, it can be a guide for you when you start it. Now let's go to optical Ethernet. Now another important application of optical Ethernet is extending the reach of the Ethernet network from local and campus network out to metropolitan and wide area network. So another beauty advantages of optical Ethernet is that it's not only limited to a local area network or campus network, as it was in twisted pair cable or twisted pair cable or shaded twisted pair cable. Okay, but for optical Ethernet, it extends beyond local area network. Okay, the connectivity or the usage extends beyond local area network to campus network, and even beyond campus network to metropolitan network, and even beyond metropolitan network to wide area network. So this is one super advantage of using optical Ethernet. Now again, optical networking is introducing Ethernet as via WAN. Okay, this one optical networking is enabling WAN. Like I said, you can see optical cable buried under the sea from London to Africa. Okay, so to enable fast speed delivery of data. Okay, so this one, it's giving us a big advantage, because with this we can connect the wide area network, which is called WAN. Okay, WAN technology is able to be developed because of the existence of optical networking. Now extending Ethernet into a wide area network is a seamless integration of technologies. So many technology has been put together, so many technology integrated together to provide this capability. Now the Ethernet extension into WAN simply requires the optical adapters such as the Gigabit interface and the ZPAC 10 gigabit ZPAC interface converter, and the 2 wire strands, one for transmit and one for receive. Okay, so this is the beauty of this. So we come to the end of this, but all this one are things we've talked about. We've talked about the synchronous optical network, we've talked about synchronous transport signal, we've talked about fiber to the business, this one fiber to the client, this to the host, fiber to the host, and so on and so forth. Okay, even if we didn't mention this one, but I'm mentioning them now. Optical Ethernet, we've talked about it. Fiber cross connect, we've talked about it. May fiber cross connect, intermediate fiber cross connect, we've talked about GBIX. okay, as an interface. Gbis just means a 1 gigabit interface that converts optical light signal into an electrical signal. We talked about IDC, intermediate distribution cross connect. We talked about IC, intermediate cross connect, or intermediate cross connect. So then we also talk about logical fiber map, the one we show for campus, and then physical fiber map. Okay, so and the physical one was the first one we did before we did the logical one. So with this, we've come to the end of this class. Thank you very much. And again, you are encouraged to continuously study with us, because we gradually become the biggest and the largest digital and technological university in the world. Thank you for joining Waidsum University, and thank you for enrolling in my class. Thank you.